Bismillahirrahmanirrahim. Welcome to the series of Computer, Organization and Architecture. So the topic of today's lecture is parts of instruction register. So what are different parts of an instruction register? How the data is stored in register, how we access the data, and how we manipulate and interpret and then perform operations according to the instructions. So let's see. Parts of ISA. Programmers write instructions or commands for processor to perform operations. Machine has to interpret it according to the programmer instructions. So the machine will put these instructions into its instruction register. So basically instruction register has three fields. Number one is addressing mode, number two is opcode, and number three is the operand. Addressing mode is optional. In some instruction, addressing mode is specified and some are not. While the second field is the opcode, that stands for operational code. That basically defines what type of operation we have to perform. So after the operational code, the third field is the operands. Operands are basically the data or the memory locations on which we perform the operations according to the operation code. So let's see all of these in detail. So the first one is operational code. Opcode is operational code which tells which type of operation has to perform. We have discussed multiple type of operations like addition, subtraction, multiplication, increment, or the comparison operations, or and control flow operations, and many more. Operational code defined in bits form, like in 0 and 1 form. So machine understand from bits that what type of operation we have to perform. All functions are opcode, like add, multiplication, increment, etc., as we have discussed. Every operational function has different bits, like plus operation has different bits as compared to the minus bits. On the basis of bits, a processor inferred that what type of operation it has to perform. Normally, operation code size is 6 bits. So with these 6 bits different combination, we can perform 64 different operations. For example, for an arithmetic calculation like 2 plus 3, here the plus sign which we use is the opcode, that is the operational code, while 2 and 3 are the operands. The next field is the operands. So what are the operands? Operands are the data or memory address of data on which we have to perform operations. So keep in mind that operands are not only the data, it can be memory address too. So we can't access operands directly. Operands has addresses. To perform operations on operands, we take operand addresses from memory. In short, operands can be a data or a memory location or a combination of both. An operand address can be any memory address, CPU register address, or input-output device address. If the data saves in register, then the processor will execute instruction faster. While if data is in memory, then first the processor has to fetch it, decode it, and then perform the actions. So this is a lengthy procedure. So saving the data in the register is a faster way to perform operations. So the next is addressing mode. Data saves in memory. We access from memory, bring it first in register, then ALU, that is the arithmetic logic unit, where all the operations are performed, all the mathematical calculations and operations are performed. So addressing mode basically depicts how we will deal with data, how the operations will perform on data. Addressing mode is optional in instruction system. Addressing modes specify how the operands will show in instruction set. It defines rules for interpreting or modifying the address fields of the instructions before the operand is actually executed. Memory addresses mode deliver flexible access to memory, letting you to easily access variables, arrays, records, pointers, and other complex data types. So addressing mode provides flexible access to memory and memory content. So operands are accessed according to the access mode. Addressing mode defines how our operands are defined in register and how they look. Addressing mode is optional in instruction set like incremental accumulator directly perform actions. There is no memory address given in this instruction. While on the other hand, add A, where A is a memory address. So where does instruction set architecture resides? Where we should place instruction set? Should we place it on hardware or on software? So instruction set can be constructed into the hardware of the processor. That is more efficient and faster for running programs. Or we can emulate it in software using an interpreter, but that is a slower procedure and a slower mechanism for running programs. Let's summarize the topic. So the instruction set consists of addressing modes, instructions, native data types, register, memory architectures, interrupt, exception handling, and external IOs. We will see all these terms in detail in the coming lectures. So first of all, we must know that what is processor and what it does. The CPU, that stands for Central Processing Unit, or the processor, performs 4 basic tasks. Number 1, it fetches the data from the memory. As we have earlier discussed that we save data in the memory. So to perform operations on the data, the processor will fetch the data from the memory and then decode it, as the software engineer or a programmer give instructions to computer in high level language. So the ISA, that is the instruction set architecture, converts these high level language into the low level language. So the processor using the ISA decode the instructions into the low level language so that the processor can understand it and perform actions according to the instructions. After that, it executes the instructions. It performs the operations on the operands. And finally, after the execution, it writes back the result to the memory and save the results into the memory. So these are 4 main basic tasks that a processor performs. There are 2 main types of ISAs. The number 1 is CISC and the other one is RISC. So the both ISA architectures, CISC, that is complex instruction set computing, and the RISC, that is reduced instruction set computing, primary job is decoding and executing the instructions. How the CISC and RISC decode and execute the instructions, we will see it in the next lecture. Thank you very much.